This is Unit 6, Polygons, Lesson 6.6, Dilation. Remember to get a date, time, location, as well as a parent or guardian sign-off. Students, please do the best you can to turn off all distractions and focus only on the task at hand. Here is a problem. You're going to finger track and read this out loud. You're going to highlight, underline keywords. You're going to draw, label, list, and cross out. Attempt to do this problem completely on your own, then restart and check your work. Pause. Welcome back. Let's see how you did. Again, you should have done this on your own, folks. Now you're checking your work. If you're simply copying, you're not really learning. Says this dam is shaped like a trapezoid. So step one, you should have pulled out a trapezoid. It has a median of 360 feet. It says the top of the dam is 3 times bigger than the bottom of the dam, which you don't know either. Find the top and the bottom of the dam. And we should have done this. Median equals base plus base over 2. Your equation should have looked something like this. Your median is 360. One base is 3x, the other base was 1x over 2, and you should have solved from there. You cross multiply. We have 2 times 360 equals 4x. Key to multiplying is not multiplying. It's factoring. I'm going to divide both sides by 4, and I know 4 goes into 360 90 times. 2 times 90 is 180. So 180 equals x. So this is 180. And then you do 3 times 180, which is 540. So one base of that dam is 180 feet across. And then the top is approximately 540. Now we're going to shift gears from shapes, and now we're going to talk about movement of shapes. Movement, and there's 4 motions of shapes that we're going to study. Today we're going to focus on one of those 4. All 4 include translation, deflection, rotation, then dilation. You need to know stuff like k-factor, counterclockwise, and clockwise. So you see our 4 motions: translation, reflection, rotation, dilation. We're going to focus in exclusively on dilation today. Now, when we're dealing with geometric motions, there are two main kinds. There's rigid motion and non-rigid motion. Rigid motions, the shape stays the same shape, it just moves around, such as translation, which means to fly. So the shape stays exactly the same, it just slides. And we have reflection, which is the flip. Again, the shape stays the same, it just reflects. And then we have rotation, which is turn. Again, the shape stays the same, but it simply moves. So we have translation, reflection, rotation, slide, flip, turn. All of these are called rigid. Why? Because it stays the same shape. It moves around. Dilation is called a non-rigid motion. Dilation means to make larger or smaller Dilation actually moves the image to be either a larger image or a smaller image. Dilation is going to change the size, so it actually changes the shape, either to larger or shrinks it down to a smaller. That's called a non-rigid motion. That's why dilation is in its own category. So the motions on the coordinate plane include translation, reflection, rotation, and dilation. Today, we're only going to focus on dilation, where a shape actually changes in size. Changes in size. There's going to be lots of formulas, if you will, for these four motions. 1, 2, 3, 4. I have chants for all of them. I highly recommend you chant with me right now. We're going to say it 3 times. To change in size, just multiply. To change in size, just multiply. Say it with me. To change in size, just multiply. Again. To change in size, just multiply. Get a beat. To change in size, just multiply. So that is dilation. To change in size, you just multiply. It's not that hard. We're going to be multiplying by something called the K factor, which is also the scale factor. Okay, let me give you a simple demo. If we want to dilate the coordinates x and y by a K factor or a scale factor, then all you do is you take that x, you times it by that K factor, you take the y, you times it by the K factor. To change in size, just multiply. If that K factor is bigger than 1, we're going to make the shape larger. If that K factor is smaller than 1, we're going to be shrinking. This will make sense as we do a couple of these together. Okay, so to change in size, just multiply. Ready? If we have xy and we want to change x times k, our K factor, and y times k. Let's have an example. Okay, we're going to draw the image of the following after a dilation centered at the origin with the scale factor of 5/3. 5/3 is our K. Okay, we have our 3 points, A, B, and C. We're on the right-hand side here. Step 1, let's get our coordinates for A, B, and C. So A is sitting at 9 and 9. B is sitting at 6 and 9. And C is sitting at 9 and 6. So we have this shape here that we are going to dilate by 5/3. Now ask yourself, is 5/3 greater than 1? Or is 5/3 less than 1? Ask yourself that question real quick. Get that in your head. Hopefully you thought that through, that 5/3, since 3 goes into 5 once with 2 left over, 5/3 is 1 and 2/3, which is greater than 1. So we are going to make a larger image here. When we dilate, we're going to dilate larger. So for each of these, we simply multiply by 5/3. We're going to do this every single time. Ready? I'll show you a little trick here. I'm going to do 9 times 5/3. Call it arrow in, arrow out. Arrow in. 3 goes into 9 3 times. So we do 3 then. Arrow out. 3 times 5 is 15. And we have our second 9, 5/3. Yes, I actually want you, I know it's exactly the same thing. I know you're arguing. You're like, Miss Way, I don't want to do it again. I don't care. You're going to do it this time. You can start taking shortcuts later, but here you need the repetition. So there's your second 9. Arrow in. 3 goes into 9 3 times. Bring that little 3 around. Arrow out. 3 times 5 is 15. There's your new coordinate. So let's plot that new coordinate, 15 and 15. Notice it's called sub A. Or A prime. Okay, let's try this one. Arrow in, arrow out. 6 times 5/3, 9 times 5/3. Yes, you already know what that is. Yes, you're going to do it again. Arrow in, arrow out. 3 goes into 6 twice. A little 2 there. 2 times 5. That gives you your next coordinate, which is 10. Arrow in, arrow out. 3 goes into 9 3 times. 3 times 5, 15. Arrow in, arrow out. We have 10, 15. So here we are at B, 10, and 15. This is B prime. Last process, 6 and 9. But this way we already did 6 and 9. I don't care. You're going to do it again for repetition. Repetition is good for the brain to develop habits. So we have 6 times 5/3, and then we have 9 times 5/3. You need the repetition, just like musicians do music drills and scales, just like athletes do drills. 3 goes into 6 twice. There's a little 2 there. 2 times 5, that's 10. 3 goes into 9 3 times. 3 times 5, that is 15. So our C prime is at 10, 15. Got that backwards. It is 9 6, not 6 9. So we're going to flip these around. Got something looked a little odd there. times 6. So we come over here, and it's 15 and 10, of course. 15 and 10, because it should be the exact same image. It's a good little check, but just a different size. If you end up with a different kind of image, you know you've done something wrong. Now you simply connect them, and you can see we have the exact same image, but it is dilated by a factor of 5/3. And because 5/3 is bigger than 1, then we know that it is an enlargement of the image, not a shrinking down. To change in size, just multiply. This page, I'd like you to do on your own. Get your coordinates. You're going to dilate by a scale factor of 1/2. You're going to redraw it, and you should notice a change in size. Pause. Do your own work. Welcome back. Let's see how you did. Okay, so we have our 3 coordinates here. We have P sitting at -6 and -2. And then we had Q at 2 and 4. And then we had R sitting at 8 and -4. And we're going to dilate by a half here. Dilate by a half. So I have -6, -2, timesing by 1/2 for both. And then here I have 2 and 4 timesing by 1/2 for both. And then I have 8 and -4 timesing 1/2 for both. Your new coordinates should have been half of 6 is -3, half of -2 is -1. So -3, -1. That's P prime. And then here we have half of 2 is +1, half of 4 is +2. That's Q prime. Half of 8 is 4, half of -4 is -2. That's R prime. When you connect it, you have yourself a shape which is exactly the same size, but just a different size, same shape, different size. Same shape, different size. Same shape, different size. In other words, folks, that should be ringing a bell. We have ourselves similar shapes. To change in size, just multiply.